Hey guys, today we are on pages 27 and 28. And so it looks like this. It says factoring ax squared plus bx plus c. So we've talked about how to factor out a greatest common factor, and now we're actually going to factor out and create problems that we multiplied earlier this week, or a couple weeks ago. So a polynomial that has three terms is called a trinomial. So we learned at the beginning of this unit what a trinomial is. So tri means three. So we just have a three-part math problem, just like how x squared plus bx plus c has three parts. Trinomials can often be factored and written as a product of two binomials. And so we'll talk about what that means. We've actually already done this. To help us factor out trinomials in the form x squared plus bx plus c, what we're going to do is we are just going to look at something that we've already done, like these two problems, and see if we notice any patterns. So what we're going to do is we are just going to simplify x plus 5 times x plus 2, which we've already done. So we're going to double distribute. So we're going to do x times x, which is x squared. And then we'll do x times 2x and get 2x. Okay. Then we'll multiply the 5 and get 5x, and do 5 times 2 and get 10. Okay. Then to finally simplify, we have to look and see if we have any common terms. So we have x squared plus 7x plus 10. So we have practiced this before where we have multiplied a binomial times a binomial. We have simplified and resulted in a trinomial. Okay. And then what we're going to do is we're going to answer these questions. How does the middle term, so the middle term is this lovely thing, okay? How does the middle term of the product relate to the binomial? So it's asking, do we know how 7x is related to this original problem, x plus 5 and x plus 2? Well, it kind of looks like it's 5 plus 2, which are these two numbers, and then you just add on an x. Okay. How does the last term relate to the product? Okay, so the last term is 10. Okay. How does that relate to the original problem? Well, 5 times 2 is 10. Okay, so that's something cool to notice. So what we'll do is we'll do another problem. Now we have x plus 7 times x minus 3. So we're going to do x times x. We're just going to simplify to look for patterns. And then we'll do x times negative 3, which is negative 3x. Now we'll do 7 times x. And then we'll do 7 times negative 3, which is negative 21. And then finally, we will combine like terms. So we get x squared plus 4x minus 21. Okay. So it's asking the same questions. So the first question is, how does the middle term relate to the product of the binomials? Okay. Well, something that I notice is that 7 minus 3, because this is a negative 3, equals 4. And then you just add on an x. Okay. The next question is, how does the last term relate to the product, or the original problem, the product of the binomials? Okay, well, the product is negative 21, and 7 times negative 3 equals negative 21. Okay. Abigail needs to factor x squared plus 11x plus 30. Using the patterns above, describe what should be true about the values of the binomials. Well, it looks like the middle term, this middle thing right here, 11x, okay, should be when you add the two numbers together. So it should look something like this plus that should equal 11. So the two numbers should add to 11. I guess I should have wrote add. Okay. Then it looks like the last term needs to multiply to, for this case, it would be 30. So we are actually going to start factoring this. The steps to factor a trinomial like x squared plus bx plus c, first we're going to check to see if there is a GCF. Because if there's a GCF, we might as well factor that out. Okay. Next, find two factors with a product of c. So it has to multiply to the last term. Okay, just like how it had to multiply to 10 and negative 21. But it also had to have a sum of the middle term, which is the sum of the b term. Okay, then use those two values to write your binomial factors. So of course, we're going to do this together. Okay, so follow the steps above to factor each trinomial below. Check your answers by multiplying. So we have this trinomial x squared plus 5x plus 6. The goal is to create two binomials being multiplied together. Okay, so what we noticed when we did these problems is it always has to multiply to the last term. So it has to multiply to 6, and it has to have a sum of the middle term. So it has to have a sum of 5. So this is always kind of fun. It's kind of like a little puzzle. So what we're going to do is we're going to write our factors of 6. Okay, so what multiplies to 6? Well, 1 and 6 multiply to 6, and 2 and 3 multiply to 6. Okay, but we also have to check the other half of the puzzle because it has to have a sum of 5. When I add 1 and 6, I get a sum of 7. And when I add 2 and 3, I get a sum of 5. So it looks like the answer to my puzzle will be 2 and 3. Okay, so to write my binomial, I'll do x plus 2 and x plus 3. Now we are going to check these because we already know how to simplify these, so we might as well just check to make sure we get the right answer. Okay, so x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. When I combine like terms, I get x squared plus 5x plus 6. And if I check at the beginning, oh my goodness, that is the original problem that I was given. So it looks like this is the correct answer. All right, the next one, we have x squared plus 9x plus 20. Okay, so our puzzle is what two factors have a product of the last term, so a product of 20, and a sum of the middle term, 9. Okay, so what we're going to do is we're going to write our factors of 20. So 20 can be created by doing 1 times 20, by doing 2 times 10. 3 does not go into 20 evenly, so we're going to skip to 4. 4 times 5. And we loop back around to 5. Okay, now we're going to find the sum because it also has to have a sum of 9. Again, you could probably like use your brain to see that it's going to be this one, but I'm going to find the sum of all of them. 4 and 5 make 9. So my factors are going to be x plus 4 and x plus 5. Okay, just to check to make sure if we get it right, we might as well just re-simplify to make sure we get the right answer. So we're going to do x times x times 5, then we'll do 4 times x, and 4 times 5. Okay, we'll combine our like terms, and we get the beginning problem that we started off with. So it looks like x plus 4 and x plus 5 are the two factors of this trinomial. All right, so now we are going to go ahead and have you try a couple. So this one, okay, it has to multiply to 8 and add to 9, okay? So I'm going to go ahead and make my table, okay? It has to multiply to 8 and it has to add to 9. So I'm gonna write my factors of 8. So 8, you can make 8 by doing 1 times 8 and doing 2 times 4, okay? When I add these together, the sum would be 9. When I add these together, the sum is 6. So it looks like my two factors will be x plus 1 and x plus 8. All right, now we're going to do the same process, but now we're going to put some subtraction in the problems. So still the same concept. Our goal for t squared plus 4t minus 12 is it has to multiply to the last term, so it has to multiply to negative 12, but it has to add to the middle term of 4. Okay, so I'm going to write some factors of 12 and not even worry about the negative right now. Okay, so I know 1 times 12 is 12. I know 2 times 6 is 12. And I know 3 times 4 is 12. Okay. And now I just kind of need to mess around with, it needs to add to 4. But right now, when I multiply them, they multiply to a positive. So I'm going to kind of play around and put some negatives. Okay, so I'm going to put 1 and negative 12. That would add to a positive 11. So that's not very close. Okay. I'm going to do negative 2 times 6 because that's negative 12. That does add to 4, so this will be my right answer. Okay. I can also check this and do negative 3 times negative 4, which is negative 12, and that would add to 1. Now let's say that we do not get the right answer with any of these three. Then what you could do is you could write the same products and check with these negatives. Because again, these will multiply to a negative 12, but will add to a negative 11. This will add to a negative 4, and this will add to a negative 1. Okay. When you get more of the hang of it, you guys can kind of notice that there are patterns and everything like that. But we are going to just start with, okay, these two factors are x minus 2 and x plus 6. Okay, final one for this right now is c squared minus 7c plus 10. So it needs to multiply to 10, but it needs to add to negative 7. Okay, so let's talk about the factors of 10. We have 1 and 10, and we have 2 and 5. Okay, when I add 1 and 10 together, I get 11. When I add 2 and 5, I get 7. So we're very, very close, but it needs to add to a negative 7. So we need to think about other factors that multiply to a positive 10. Well, a negative 1 and a negative 10 do multiply to positive 10, and so does a negative 2 and a negative 5. Okay? So negative 1 plus negative 10 would have a sum of negative 11, and negative 2 and negative 5 would have a sum of negative 7. So this right here fits my puzzle. So my factors are x minus 2 and x minus 5. Okay. Now we're just going to kind of reflect which trinomials had a positive c value. So again, the generic form right now that we're talking about is x squared plus bx plus c. So right now it's asking which had a positive c value. So it looks like 3 did and 5 did. Okay, it asks, how did this affect the signs in the binomial factor? So now if we look at our answers, how does that affect our answers? So for this one, we had addition for both problems. And for this one, we had subtraction for both factors. Again, that does kind of make sense because this is what has to multiply to. So you can either get a positive number by multiplying two positives or getting a positive by multiplying two negatives. Okay, which trinomial has a negative c value? Okay, so it looks like number 4 had a negative c value because it was negative 12. How did that affect the signs of the binomial? Okay, what if I look at my answer? Okay, the factors. Looks like one had to be a subtraction sign and one had to be an addition sign. And again, that makes sense. When we multiply a positive and a negative, we would get a negative c value. Okay. At times, there are going to be no factors of c with a sum of b. There'll be some problems that don't fit the puzzle. The puzzle just isn't going to work. In this case, a polynomial cannot be factored, and we will call that a prime trinomial. Okay, so we're just going to go ahead and try these problems out. So I look for a GCF first. This one doesn't have a number, and there's not an M in all of them, so we're ready for our puzzle. So it needs to multiply to 14, but it needs to have a sum of -9. Okay, so I'm going to go ahead and write my factors of 14. So that would be 1 and 14, 2 and 7. Okay. Now it has to have a sum of -9. So right now I know these are going to have a positive sum. Okay, so I think about what also could happen. Well, if they're both negative, that will have a sum of a positive. Okay, so this has a sum of 15. This has a sum of 9. This has a sum of -15, and this has a sum of -9. So it looks like the two factors that are going to fit my puzzle are going to be x minus 2 and x minus 7. Again, when you get the better hang of it, I'm not saying you have to write out all your factors every single time, but I will do that for my notes. Okay, next problem, x squared minus 5x plus 1. So we have to write out, again, look for a GCF first. There's looks to be a GCF. So the puzzle is what multiplies to 1 and adds to -5. Okay, well, 1, the factors of 1 is just 1 times 1, or -1 times -1. Okay, the sum of 1 and 1 is 2. The sum of -1 and -1 is -2. So there doesn't seem to be anything that fits our puzzle. So we will call this prime, which means there is no way to right now factor this trinomial. Okay, last problem, b squared minus b minus 30. Okay, so we're looking for what multiplies to -30. So we're going to write the factors of -30, but it looks like it has to add to -1. Okay, so we'll start off with our factors. We have 1 and 30. We have 2 and 15. We have 3 and 10. Forward is not divisible by 30, so we'll do 5 and 6. Okay. And again, right now, we know it needs to be a -30, so that means that one of these factors has to be a negative sign. Okay. So I'm just going to kind of play around. I'm going to just start off with these all being negatives. Okay. This would have a sum of 29, a sum of 13, a sum of 7, and a sum of 1. Okay, so if I'm looking for what's close, it looks like this one is very, very close. So what I'm going to do is I'm going to check this one. Again, 5 times -6 does have a sum of -30. But when I add them together, it gets the sum that we want of -1. So the better you get at this, the more that you practice, you might not even have to write out the list. You might just be like, I know that 6 and 5 make 30, and the 6 would have to be a negative. Again, you don't have to write the list as you continue to get better at this. Okay, so my factors will be x plus 5 and x minus 6. Okay. Darren factored a trinomial and ended up with two binomials in the form of x plus something times x minus something. Mark each statement as true or false. Darren's trinomial must have a negative c value. So again, it's asking this question right here. This last term, okay, does it have to be a negative? And if I think about what I'm doing, if I were to simplify this, is I would multiply and multiply, and I would get and then at the very end, I would multiply a positive times a negative. So this seems to always be true because a positive times a negative at the very end, when we do this very last step, will always equal a negative. Okay, Darren's trinomial must have a negative b value. Okay, so it's saying right now is this b value has to be a negative. Okay, well, I think it kind of just depends. Okay, because if I have a problem like this, okay, when I multiply right here, I'll get 10x, and when I multiply right here, I get -1x, so it'll actually be a positive. But if I were to flip those problems, then it would be negative 10x and positive 1x, which would result in a negative b value. So this really depends on what these numbers are and where they're placed. All right, the final problem. The area of Mrs. Cocker's rectangular pantry can be expressed by x squared plus 11x plus 12 units squared. List a possible expression for the length and width of the pantry. Okay, so again, it's telling us that the area is x squared plus 11x plus 24. Okay, what it's asking us right now is to find what is the length of it and what would the width of it be. Okay, so it looks like I'm gonna have to factor to come up with this. So my puzzle is it has to multiply to 24 and it has to add to 11. Okay, so the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 6 and 4. Okay. This has a sum of 25. This has a sum of 14. This has a sum of 11. Woo! This has a sum of 10. Okay, so it looks like my factors are going to be x plus 3 and x plus 8. Okay, so my length would be x plus 8 and my width would be x plus 3. All right, so for today, guys, we are just going to practice a little delta math just to make sure we feel comfortable with the basic concept of factoring.